Okay, so we're going to do some vector algebra. We're just going to have a very simple problem where we are interested in vector C, which is equal to A plus B. And we're going to look at what is the magnitude and direction of vector C, given vector A is 5, has a magnitude of 5 at an angle of 34 degrees, and vector B has a magnitude of 7 at an angle of 156 degrees. Well, keep in mind, to add vectors, we can only add their components. We can't just add these two numbers up. But we can add the numbers up as long as they're in the same direction. And the easiest way to do that is to break them into their components. So we're going to break each vector up into its horizontal and vertical components, and then we can do algebra, basic algebra addition, to get the resultant vector's horizontal component, the resultant vector's vertical component, and then pop it back together to get that resultant vector in full. So, vector A and vector B. So, vector A, if I am always referencing my angles to the positive x-axis, and in the absence of any additional information, that is the assumption that we make in science, that an angle provided is with respect to the positive x-axis. Any angle with respect to the positive x-axis, any vector, will have a horizontal component that's equal to the magnitude of the vector times the cosine of the angle, and a vertical component that's equal to the magnitude of the vector times the sine of the angle. And just to keep in mind, this is true always if theta is relative to the positive x-axis, okay? So I can use that if my theta is relative to the positive x. If it is not, if it's just an angle that we're provided given a specific direction of that vector, we have to make sure we understand the physics and the true direction of that vector. All right, so the horizontal component then of vector A will be 5 times the cosine of 34, and the vertical component will be 5 times the sine of 34. Well, 5 cosine of 34 is equal to 4.14. I'm going to go 3 significant figures until I get to the end, and then 5 sine of 34 is equal to 2.79. Both are positive, which I expect it to be because 34-degree angle is certainly in the first quadrant. All right. Vector B, we have 7 times the cosine. Again, this is given to us in terms of the positive x-axis, and 7 times the sine of 156 degrees. Well, 7 times the cosine of 156, my calculator gives me a negative 6.39. I expect it to be negative. 156 is in the second quadrant, and therefore my x component, my horizontal component, should be negative. And 7 times the sine of 156 is 2.85. And that should be positive. Again, I'm in the second quadrant. Now, I have my vectors into their respective components, so I can add the numbers. I can add numbers in the same direction. So when I do that, I get 4.14 plus a negative 6.39. My horizontal component is negative 2.25, and my vertical component, 2.79 plus 2.85, is 5.64. So this is my horizontal component. This is my vertical component for this resultant vector C. So how do I get my magnitude of C in my direction? Well, this is that trigonometry Pythagorean theorem. So the vector C is going to be the square root of the horizontal component squared plus the vertical component squared, which is the square root of negative 2.25 squared plus 5.64 squared, which equals 6.1. And my angle is the inverse tangent of the vertical component over the horizontal component. So that's the inverse tangent of 5.64 over negative 2.25, and that equals negative 68.3 degrees. Now, this is where I have to stop and check. Remember, the tangent, the inverse tangent, is only going to be provided for the first and the fourth quadrant. This is in the fourth quadrant. Negative 68, negative relative to the positive x-axis, is in the fourth quadrant. Is my vector in the fourth quadrant? If it is, great. I am good to go. But if it isn't, I have to adjust this vector to appropriately account for the quadrant that it is in. So I'm going to look up at my vertical and horizontal components. If I have a negative horizontal component, I'm pointing to the left. If I have a positive vertical component, I'm pointing up. Well, the only way I can get a vector that's to the left and up is if I'm in quadrant 2. This is not in quadrant 2. So how do I get that value into quadrant 2? Because, again, this ratio for my calculator doesn't matter if the negative's on the top or the negative's on the bottom. It's going to give me the same value, and therefore it only gives me that value in quadrant 4. So in order to get the true vector, in this case, I have to always look at the physics. I have to look at what I really am. I'm going to add 180 degrees. So if I add 180, I end up with an angle of 112. So there is my magnitude of 6.1 and my angle of 112 degrees. All right, keep track of those angles. They can be tricky. Good job.